Let's take a look at how these 5 pillars might translate into code by creating a new application. We'll begin by creating a class warehouse. Previously, we had created our classes all in the same file, but it's much more common and better practice to create them each in their own file. To do that, we come over to the Solution Explorer window. In the Solution Explorer is both the solution and the project. In this case, we're working only on a single project. Let's right-click the project and choose Add and then Class. Our Add New Item menu will open, and we can name our class and save it, and a new window will open with the class ready to go. Class Warehouse is our class. The most important method in our warehouse class is find and return an item. We can make that public because we know it's part of the narrow public interface. And we'll have it return an object because we don't know what type of object will be requested. Give it a name, find and return item. And we need to give it some kind of parameter. How will the caller of this method identify the item they want? Well, let's have it that they will identify it with an item ID. Then we will do some sort of work to find and return their item. Notice the red squiggly line. That's because we don't have a return statement, and we've defined that we're going to return an object. We can, in fact, improve this right away. We know we want to return an item, which is some type of object, but it's more specialized than an object. It's a specific kind of object. And so let's say that we're going to declare a class called item, and we will return an item based on its item ID. Notice that in addition to a red squiggly line under item, there is a small blue line. If you hover over that blue line, a tab opens, and if you click on that, the options for how to fix the red squiggly line come up. And one is generate class for item. Let's go ahead and do that. Interestingly, Visual Studio created a new file called item.cs, and in that file it created a class item for us. We know that our item is going to have an ID, so let's go ahead and put that in right away and save that class. Returning to the warehouse class, we now know that we can create an item and find it and return it. And normally what we would do here would be to search through a database looking for an item that matches the item ID. For now, what we're going to do is just make an item that matches the item ID. To do that, we declare an object of type item. Let's give it a name and say new item. Now at this point, we either need a constructor that's going to take the item ID, or we need to initialize the item ID. However, if we say return item dot, we don't see item ID. It's not in the public interface of item. Let's go back to item and fix that. Notice we did add an ID, but the default visibility is private. If we want that to be public, we must specifically mark it public. We don't want to make a field public, so what we will do is make this be a property. Now that that's a public property, we can go back to warehouse. We can set the ID in the initialization to whatever value we think is correct. Let's set it to 101. And now we've initialized that new item with an ID of 101. And to keep this incredibly simple, we can then just return our return item. And notice the red squiggly line goes away, because now we have fulfilled the contract of this class, which says that we're going to return an item. We don't want to set the ID to 101, however. We want to set it to whatever ID was passed in. So let's change this to item ID. Now this substitutes for searching through the database for a matching item and returning it. Let's go to our item class. We know that it has an ID. What else might it have? Well, every item has a name, so we can give it a name. Let's go back to our warehouse class. What else might the warehouse have? Well, for one thing, it probably has an ID, because there's probably more than one warehouse. And once again, we want to make that be a property. We can also give our warehouse a name, and you can imagine a number of other properties. While we're here, let's give our warehouse a constructor, and that constructor will take a name and an ID. We can assign the warehouse name to the name that was passed in. But notice that the public property ID is all caps, and the ID that was passed in is all caps. We need a way to differentiate between them. In order to do so, we use the keyword this. This refers to the current object. Every method, including the constructor, receives a hidden parameter, which is the this reference, the this keyword, that is used to refer to the current object. So I can say this.id equal ID, and there is no ambiguity. That says assign to the ID of this object the ID that was passed in. Let's go back to our main program and wire up a request to the warehouse for an item. The first thing we need to do is to create a new warehouse item. Notice that the constructor for warehouse wants a name and an ID. So we can call it warehouse1, and we can give it the ID 101. We now have a warehouse, and we can request an item from that warehouse simply by saying new warehouse dot, and we look for the public methods, one of which is find and return item, open parentheses, and it says you need an item ID. Let's pass in 101 for the item ID. What we're going to get back from new warehouse find and return item, if we hover over, we can see that we get back an item. So we're going to say var my item equal new warehouse find and return item, and what we'll get back in my item is an item. We know that items have a couple properties. They have an ID and a name. Let's go into warehouse and see if we assign an ID and a name to the item. No, we just so far assign an ID, so let's go ahead and assign a name too. Name equal Microsoft Office. So now our item has a name and an ID, and in our program we can say console right line my new item is my item.name. So understand the relationship here is that we're asking for a new warehouse. Once we have that warehouse, we're calling find and return item 101. The job of the warehouse is to return the item, but it doesn't know anything about the item except which item to return. But we can ask the item for its name. Let's run the program. And it says my new item is Microsoft Office. So here we see three objects interacting with each other, each with its own responsibility. The program acting as the main representative of the customer, the warehouse object encapsulating its own ID and name, and having a constructor and a method find and return item, and the item class having just two properties, ID and name. Of course, in a real program, we would flesh these out and give each of them more properties and methods consistent with their specific area of responsibility.